Welcome to ALP Chemistry on Video. The lesson for today is on Chapter 4 of Zumdahl and Section 4.10 on ions. And this is a live recording, and we have Darlene with us for the lesson today. So if you hear some questions or if I wait for some comments, I'll be talking with Darlene. I'll try to remember to repeat the questions just so you can hear them as well. So far in the chapter, you've been learning about atoms. And in an atom, you have protons in the nucleus, and you have neutrons there as well, and you have electrons moving around outside the nucleus. So that's what an atom is. And an atom has positively charged protons, negatively charged electrons, and neutrons which don't have any charge. In an atom, the number of protons is the same as the number of electrons, so the number of positive charges will equal the number of negative charges, so an atom doesn't have a charge. But if the number of protons and electrons was to change, then the atom would end up with a charge. And that's what an ion is. An ion is a charged atom. And how it gets the charge is by either adding or removing electrons from the atom. The protons won't move because the protons are locked in the nucleus. You can't get them out except by way of nuclear reactions, and you need a nuclear reactor to do that, or a star. Nuclear reactions also happen inside stars as well. So on Earth, it's relatively unusual to have the protons move. But the electrons can move fairly easily because they're outside the nucleus, they're moving around, and it's relatively easy to either put electrons in or take electrons out. So in a chemical reaction, it's only the electrons move, the protons don't move, and like I say, you can only move the protons in a nuclear reaction. So let's take hydrogen as an example. Hydrogen being the simplest of the atoms, simplest of the elements, and in hydrogen, you only have one proton, one electron. If we were to remove that electron from the atom, we'd only be left with the proton, so we'd be left with a positive charge. The process for doing that, we write in this form as a chemical equation, where you have a hydrogen atom going to make, or producing, or in chemistry, the arrow we say yields. So hydrogen atom yields a hydrogen ion with a positive charge and an electron. So the electron has gone somewhere else, leaving us with the hydrogen ion. Most often, hydrogen atoms lose an electron, but sometimes, under the right conditions, you can make hydrogen gain an electron. And if we were to write that process, we would write it as a hydrogen atom gaining an electron, or a hydrogen atom and an electron yields a hydrogen ion with a negative charge. So Darlene's question is the electron negative? And yes, electrons have negative charge. Okay. So let's take sodium. So we've done hydrogen. Let's take sodium as an example. Sodium has atomic number 11. What that means is that if you have a sodium atom, it will have 11 protons and 11 electrons. So over here, we have a sodium atom with 11 protons and 11 electrons. So if sodium was to lose one electron, it would be left with 10 electrons. So here we show sodium losing an electron, and it will be left with 11 protons, which will be 11 positive charges, and because it's got 10 electrons, it only has 10 negative charges, and if you add up all the charges, it has an excess of one positive charge. 11 positives, 10 negatives leaves you with one positive. And that's where the charge that we show here comes from. So a sodium ion that we make by losing an electron has a one positive charge, and we just show it as a positive charge above the symbol. And in chemistry, for some reason, we don't show ones. So a lot of times when you see Chemical formulas, you won't see the ones, and the ones are assumed to be there. And that's just tradition. I'm not sure how that came to be, but a lot of times you don't see ones. So here, if you just write see Na plus, that means Na1 plus. Or if you see Na minus, or it would be Na1 minus. Na plus is the sodium ion. So positively charged ions, called cations, when we name them, we just use the name of the element and ion. So if you're talking about the ion, you need to specify that it's the ion you're talking about. If you just say sodium, people will assume it's a sodium atom. So if you're talking about the ion, you need to say sodium ion. Positively charged ions are called cations. The reason for that is that if you have an electrochemical cell, like a battery, there are two electrodes. One's called the cathode, the other's called the anode. The ions that are associated with the cathode are positively charged, so they call those the cations. The ions which are associated with a negatively charged electrode are the anions, so that's why they call them the negatively charged ions anions. The anions are associated with the anode. To name a cation, we use the element name followed by ion. And in chemical reactions, charge is conserved, which means you have to have the same charge on one side of the reaction as on the other. So we go up and we look at the example above. Here, we have sodium, and an element by itself has zero charge because it's 11 protons, 11 electrons. Positives and negatives cancel. So this sodium here has zero charge. If we were to put a charge here, and normally they don't put it, it would be a 0. Over on this side, we have one positive and one negative charge. So one positive, one negative adds up to 0. So it's kind of like an equal sign, where you have an equal sign. So we have, with this arrow here, the arrow is kind of an equal sign with a direction. So it's kind of like an equal sign in a math problem, where everything on one side of the equal sign has to be the same as everything on the other side of the equal sign. Well, that's how it applies in a chemical reaction. The charges have to be the same on the left side of the arrow as they are on the right side of the arrow. So if you count up all your charges, they've got to be the same. They won't always be 0. Sometimes you may end up with a charge on one side, but it will have to be the same charge on the other side. So let's do another example. We've got magnesium, and a magnesium atom has 12 protons and 12 electrons. And magnesium, when it forms an ion, typically loses 2 electrons. So if it loses 2 negative charges, it's going to be left with 2 positive charges. So a magnesium ion is typically has a 2 plus charge. So 12 protons in this nucleus, 12 positive charges. 12 electrons minus 2, leaving you with 10 electrons. You end up with 2 positive charges. So this leads to the question, if I say magnesium typically loses 2 electrons to form an Mg2 plus ion, how do we know how many electrons an atom will gain or lose? The answer to that is that what elements like to do is they'd like to have the same number of electrons as the nearest noble gas. So the noble gases are the elements to the furthest right of the periodic table. So it's that last column in the periodic table, which would be column number 18. And that group is called the noble gases. And the reason they're called the noble gases is because they're snobby. They don't like to react with anyone. They don't want to associate with anyone. So in that case, in that sense, they're snobby or noble. So if we were to now do aluminum, let's do what we've done for magnesium with aluminum. So except now we're going to do, before I had the equations up, we're going to make the equation here. So let's say we are starting with an aluminum atom. An aluminum atom will have 0 charge because it's just an aluminum atom. Aluminum, being atomic number 13, will have 13 protons, 13 electrons. That adds up to a negative charge. So when aluminum forms an ion, we want to know what charge that aluminum ion will take. The way we'll know that is if you look in the periodic table, find the nearest noble gas. So you find aluminum, which is number 13. You have two choices. If you go to the right, you'll end up at argon. If you go to the left, you'll end up at neon. So you have to go back up one row to get to neon. So you can go right, but to get to argon, you would have to do 1, 2, 3, 4, 5 skips to the right. To get to neon, you only need to do 1, 2, 3 skips to the left. So it's closer to get to neon. So what aluminum will do is lose 3 electrons to get the same number of electrons as neon. So if aluminum loses 3 electrons, it's going to lose 3 negative charges, and that means it will end up with an excess of 3 positive charges. Because in the aluminum atom, your positive and your negative charges cancel out. But if you lose 3 of your negative charges, you're going to end up with 3 positive charges. So that's how you tell what charge an atom will take when it forms an ion. Count skips to the nearest noble gas. And for aluminum, it's 3 skips to the left, which means it's losing 3 electrons. Because it loses 3 negatively charged electrons, it ends up with a 3 positive charge. Now, a lot of people have trouble figuring out where the electrons should go in this type of equation. So we know what charge the ion takes, but now we need to know, do the electrons go on the left side or do they go on the right side? What you do is balance the charges. So they'll have to go on the right, because if we were to put the electrons on the left side, that'll make the left side negative. But the left side has a 0 charge. It'll just make the left side negative. It won't help us balance. But here we have a positive charge. If we add negatives on the right side, it will cancel out the charge. So what we need to do is add 3 negatively charged electrons. So the electrons will go on the right side. That way, if you add up 3 plus 3 negative equals 0 charge. So add the electrons on the side that will balance your charge. And when you write these equations, we never show negatives, so we wouldn't write Al minus 3 electrons. We're always doing positives. So those electrons have to go on the right side to balance the charge. We never show subtracting things in chemical equations. I'll show you an example with a negative charge. That's what we'll do next. So this will be an example with a negative charge. So we'll do fluorine. And if you find fluorine in the periodic table, which is on the top left, atomic number 9, the nearest noble gas to fluorine is neon, and it's 1 skip to the right. So that means it's going to add 1 electron to go from 9 electrons to 10 electrons. So because fluorine is getting 1 extra electron, and remember electrons are negatively charged, that means the ion that you make from fluorine will have a 1 negative charge because it's gained 1 negatively charged electron. So that will be the process, going from a fluorine atom to a fluorine with a negatively charged ion. And again, we need to figure out where the electrons are going to go. They can't go on the right, because if we put electrons here, the right side is just going to get more negative. So they're going to have to go on the left side. And we only need 1 electron, so we'll just write it as E minus plus F will give us an F negative ion. So that's the process. Now it doesn't matter whether the electron comes first or the F comes first, either way. It's kind of like addition. You do 1 plus 2, 2 plus 1. They both equal 3. It doesn't really matter. So I can write the electron first, or I can write it second. So negatively charged ions are called anions, as I mentioned, because they're associated with the anode of an electrochemical cell. And if you want to name an anion, you drop the ending of the element name and add IDE, or IDE. So F minus is called fluoride ion. In this case, you don't really have to specify the ion. With a cation, you should specify the ion. So the Al3 plus would be aluminum ion. But here fluoride is enough because it's different from fluorine. If you say fluoride, people will know that you're talking about the ion. And this stuff, fluoride, is the same stuff in your toothpaste. Your toothpaste contains sodium fluoride, and that's referring to F minus. Let's look at another one. Let's look at oxygen. Oxygen, find oxygen in the periodic table, atomic number 8. And what is the nearest noble gas to oxygen? A noble gas. The nearest noble gas. Remember, the noble gases is the column furthest to the right of the periodic table. The very last column in the periodic table are the noble gases.
To the right? This one?
Yep. So what is the nearest noble gas to oxygen?
The nearest one would be, I don't know if you can go up here and over, or...
There's two ways you can go. You can go 2 skips to the right, which would take you to neon, or you would go 1, 2, 3, 4, 5, 6 skips to the left to get to helium.
So you'd want to go with the neon.
It's closer to get to the neon. It's 2 skips. And because it's 2 skips, oxygen, when it forms an ion, is going to gain 2 electrons because it started with 8 electrons. It's going to gain 2 to get 10. And if it gains 2 electrons, what's the charge going to be on oxide ion? -2, because it's gaining 2 electrons, and electrons are negative. And that confuses people sometimes because you're adding things, but you're adding negative things. So when you're adding something that's negative, you're going to get more negative. So because oxygen is gaining 2 negative electrons, it gets a 2 minus charge. Now where do we put the electrons here in this equation? Right or left side?
Right side. Left side, because otherwise it's just going to stay negative.
Excellent. They have to go on the left side because if you were to put them on the right side would just get more negative. So correct. We need the electrons on the left side, and we need 2 of them so that we'll have 2 negative charges to balance out the 2 negative charges on the right side. And the name of this ion would be oxide ion, or just oxide. Oxide's enough to specify the name. Metals tend to form cations. Non-metals tend to form anions. And the metal-non-metal divide is the staircase that starts just below boron and runs diagonally down the periodic table. So it runs from boron down to astatine in a staircase. Below and to the left are the metals. Above and to the right are the non-metals. So the non-metals tend to form negative ions. The metals tend to form positive ions. So most of the elements in the periodic table tend to form positive ions. The exception to the counting skips to the nearest noble gas rule are the transition metals. The transition metals are the elements right in the middle of the periodic table, and they follow their own rules. You can't count skips to the nearest noble gas to figure out their charges. They kind of do their own thing. So they're a little hard to figure out. So later in the course, I'll tell you how to figure out their charges. And it's really a question of reading them off the periodic table, because they're not that easy to figure out in terms of their charges. You need a 2nd or 3rd year inorganic chemistry course, university course, to figure that out. But there is a way to read them off the periodic table, and I'll tell you that when we get to chapter 5. Okay, let's do nitrogen now. So find nitrogen in the periodic table, atomic number 7. How many skips to the nearest noble gas for nitrogen?
3.
Good. 3 steps to the nearest noble gas. To the right or to the left?
To the right.
And to the right, are you gaining or losing electrons? If you're going to the right.
Losing.
Gaining electrons. If you're going to the right, you're adding electrons. and you're adding negative charges. So what would the charge on the nitrogen ion be? The ion that you make from nitrogen?
It would be
Adding 3 negative charges, because you're going to the right,
yeah.
going from 7 electrons to 10 electrons. So you're adding 3 negative charges. So the ion that you get from nitrogen will have a 3 negative charge. Where do we need to add electrons to the equation to balance the charge? To the right side or to the left?
Right side.
Can't add them to the right, because if we add them to the right, it'll just get more negative.
Just right to the left side.
So we'll have to add them to the left side. And we'll need 3 of them, because we have 3 negative charges on the right. And the name of the ion that you make from nitrogen?
The name of the ion.
Yep. The rule for negative ions is you drop the end of the element name and add "-ide". So nitrogen would become "-ide". End it with "-ide". Drop the ending off nitrogen and add "-ide". Close.
No.
Close. Not "nitride",
It's nitro.
and it's not "nitroide". Again, that's close. Somewhere in between "nitide" and "nitroide". It's nitride. Nitride. So oxygen becomes oxide, nitrogen becomes nitride, fluorine becomes fluoride. Okay. What about carbon and silicon? So we know that you could go, for some elements you can go left. You go to the nearest noble gas, either left or right. But carbon and silicon sit right in the middle. So for aluminum, it's 3 skips to the left. For nitrogen, it's 3 skips to the right. Carbon, it's 4 skips either way. So it's equal distance from the nearest noble gas. So these can either gain or lose electrons. They can gain 4 or lose 4, but most often they prefer to share. So rather than losing electrons completely, they prefer to share electrons. And they'll share 4 normally. Okay. So now let's do the groups in the periodic table. We've already mentioned the noble gases. And let's put the charges for the ions in. So this is something you might memorize. You can count skips to nearest noble gas, or you can memorize this. Some people prefer to do one or the other. Group 1 in the periodic table is called the alkali metals. That's the family name for group 1, the very first column in the periodic table. They typically form a 1+ charge ion, because it's only 1 skip to the nearest noble gas. Group 2, which is the second column in the periodic table, is called the alkaline earth metals. So it's close to the name of the alkali metals, but slightly different. So alkaline earth metals, and they typically will form 2+ ions, because it's 2 skips to the nearest noble gas. The aluminum family doesn't really have a name, but 3 skips to the nearest noble gas, so it'll be 3+. Carbon, the carbon family again doesn't really have a name, so they could be 4+, 4-, or share, and they usually prefer to share. The nitrogen family is normally 3-. Oxygen family normally 2-, because it's 2 skips to the right to the nearest noble gas. The halogens is the name of the second last column in the periodic table, and they're 1 skip to the nearest noble gas, so they gain 1 electron and get a 1 negative charge. The noble gases don't like to form ions. They're quite happy the way they are, thank you very much. So they normally won't take a charge. Transition metals vary. Transition metals are all over the place. So again, those are the metals right in the middle of the periodic table, and there is no simple rule for them, and you'll learn about those in Chapter 5. Okay, So let's do some examples here. I've got the atomic number for some elements, and what I'd like you to do is to work out the equation for ion formation. So let's do the first one together, and then I'll get you to do the others. So find element number 53. What element is 53? Iodine. Iodine. Okay, so iodine has the symbol I. How many skips to the nearest noble gas for iodine? 1. And is it left or is it right? To the right. 1 to the right. So what charge will the ion that you make from iodine have? It'll have a negative charge. That's good. A 1 negative charge. Now where do we put the electrons to balance the charge? On the left side, and how many do we need? Just 1. Because we only have 1 negative charge on the right. And that does it. And that's all there is for the ion formation equation. So I'll pause the recording now and then get you to work on the others, and then we'll keep going after the answer's out. So what element is number 38? SR is strontium. That's right, strontium. And how many skips the nearest noble gas for strontium? 2. And is it to the left or to the right? To the left. 2 skips to the left. So what charge will strontium have then? A 2 positive charge. So where do we need to put the electrons now to balance the charge? On the right side. So we put 2 electrons here, and that balances the 2 positive charge. So you have 0 charge on the right, 0 charge on the left, and we're done. Okay, number 55. What's number 55? CS, which is cesium. And how many skips the nearest noble gas for cesium? 1 to the left or to the right? To the left. So that means cesium is going to have what charge when it forms an ion? Just a positive charge. Good. Where do we need to put the electrons? On the right side. And how many do we need? Just 1, because we have a 1 plus charge, so we just need 1 electron. Good. Okay, number 13. Aluminum, yeah. So start with the aluminum atom. We're going to the aluminum ion. How many skips to the nearest noble gas? Nope. The noble gases are the ones on the very last column. Yep. So you have a choice. You go 5 to the right or 3 to the left. It's closer to go to the left. Yeah. So 3 skips to the left gives you a what charge? A 3 positive charge. Good. And where do we put the electrons and how many? On the same side as the positive charge, and we need 3 of them. Good. Element 16. S, yep.
And I got 2 negative on the right.
And it's 2 negative charges, S2 negative. And how'd you know it was 2 negative?
Because I went to the right.
2 skips to the right to get to the nearest noble gas. Correct. Now where do we put the electrons?
On the left.
On the left side now, because we need to balance out the 2 negative charges that are on the right side. Good. Element 36. Kr. And this is a trick question. It doesn't form an ion.
I know.
It's a noble gas.
I left it like that.
Yeah.
I kind of did that, and I went, I know who told me that.
So I was wondering if I could catch you with that one. It's a trick question. They don't like to form ions. So it doesn't do anything. Okay, and the last one is 88. Ra, radium.
2 skips to the left.
2 skips to the left, which will make it what charge? 2 positive is correct. And where do we put the electrons? On the same side. Good. Excellent. Okay, so you've got the equations for ion formation now. Aluminum. You need the aluminum one, so I can scroll back and give you that one again. Okay, we're ready to go on. Okay, all gases that are in the periodic table, except for the noble gases, in nature are found as diatomic molecules. So in other words, hydrogen, when you find hydrogen in nature, it's found as two hydrogen atoms stuck together, or H2. Nitrogen, and you're breathing nitrogen right now because most of the gas in our atmosphere is nitrogen, and it is actually two nitrogen atoms stuck together, or N2. Oxygen is O2, and if you ever see a paramedic with an oxygen tank or a scuba diver, they'll often just call it O2 for oxygen, and that's why. Fluorine is F2, chlorine is Cl2, for example. And the halogens also, the other halogens, bromine and iodine, are also 2s. And you should really memorize these. And the easiest way to memorize them, and this I learned from a student, is the 7-up rule. You start with element number 7, which is nitrogen, and then you go to the right to the halogens and down, making a number 7. So nitrogen is number 7. To the right to fluorine and down makes a number 7. The up is hydrogen. So 7-up. And that's how you can remember which elements are diatomics that are found as 2s.
It would be all the ones to the right, like these ones are all diatomic.
Yes, correct.
These ones here.
Yep. So those are all diatomic. And sulfur, you don't have to remember these two, but just for your information, sulfur is sometimes S8 and phosphorus is sometimes P5. But I won't require you to remember those ones. Okay. Now, knowing that, if hydrogen in nature is found as H2, we also need to be able to write the ion formation equation. The only difference is we have to balance the atoms first. So each hydrogen we know normally loses one electron to become H+. Here we have two hydrogen atoms stuck together. But once they become ions with a charge, they'll repel each other. And they'll go away from each other because two positive charges won't want to stick together. Like charges repel each other. So instead of putting the 2 on the bottom right, we put the 2 in front. And that indicates that you have two separate things. So in chemistry, a little 2 to the right means that you have two things stuck together. A big 2 out front means you have two separate things. So when we write this, first thing is to write the element with its charge. The next thing is to balance the number of elements, and the last thing is to balance the charges. So that would be the steps that we would do that.
So is it always written that way? When the H2, no matter what it is, it's stuck together.
Yep, it'll always be written that way.
Separate.
Yep. Okay, so I've already said this. Number in front, that means that that number times whatever follows. So 2H+ means 2 times H+. A number subscripted on the right, a little number to the right, refers only to the elements immediately left, means they're bonded together. And we normally don't show ones. So let's do another example of that. So nitrogen, now you know nitrogen is 3 skips to the right to get to neon. So nitrogen, when it forms an ion, will normally form a 3- ion. So first step when you do these is to put the element as an ion with the correct charge. The next thing is to balance the number of ions you should have. Well, we started with 2 nitrogens on the left, so we're going to have 2 ions on the right, but now the number has to go in front because they're not going to stick together anymore because they have charges that are going to cause them to repel each other. The last thing is to balance the charges by putting electrons in. On the left side we have 0 charge. On the right side, each nitride ion has a 3- charge, and we have 2 of them. That means we have a total of 6 negative charges on the right. 2 times 3 is 6 negative charges. That means we'll have to have 6 negative charges on the left, and we'll need to add 6 electrons. Okay. Now we have the question, when forming ions, where do the electrons come from and where do they go? So we know that metals will lose electrons when they become ions. So where do those electrons go? Well, because the nonmetals want to gain electrons, if you can get both happening at the same time, they'll work out an arrangement and just trade electrons. So you might have a sodium atom wanting to lose an electron, and it'll give up its electron. And if you happen to have a chlorine atom around wanting to gain an electron, they'll do a trade. So you end up with positively charged ions that attract each other, and that force of attraction between them is called an ionic bond. And compounds formed from ions are called ionic compounds. Some things to know about ionic compounds. Well, obviously they contain ions. They're made from metals and nonmetals, because you need the metals to give up the electron, the nonmetals to gain them. They have to have 0 overall charge. A compound can't have a charge. So compounds won't have a charge. In order for that to happen, you have to have both cations and anions. You can't have 0 charge if you only have cations or if you only have anions. So you have to have both. And the number of cations and anions have to be the same, such that when you add up all your charges, the overall charge is 0. So for potassium ion and chloride ion, the formula would be K plus and Cl minus. You need 1 positive potassium ion, 1 negative chloride ion, and that gives you the formula. When you're working out a formula, I normally leave the charges in. Once I know how many atoms or ions I have, then you don't have to put the charges in anymore.
So that's 1 each.
1 each, yeah. And the metal always goes first when you do these. Like I say, it's okay to show the charges, but not necessary. So you could write it as K plus Cl minus or just KCl. When you're figuring out how many of each ion there are, normally you will need to put the charges in, but once you know, you can take them out again. So another example, Mg2 plus and O2 minus. What you need is 1 Mg2 plus and 1 O2 minus, and the 2 plus and the 2 negative charges will cancel out. And then you could write the formula as MgO. For Mg2 plus and Cl minus, you actually need 2 Cl minuses to cancel out the 2 positive charge in the Mg2 plus. And you write that with a 2 bottom right. And if you add up your charges, 2 plus, 2 minus gives you 0 overall charge. And you can write that as MgCl2. And for Al3 plus, you have 3 positive charges. With Cl minus, because Cl minus only has 1 negative charge, you actually need 3 Cl minuses to cancel out the 3 positive charge in the Al. And these are some ion chips. I have these actually in the lab, and I've just scanned them here. And the way they work is to show how to make ionic compounds and get their formulas. So for H plus and Cl minus, you have 1 positive, 1 negative charge. So the formula would just be HCl. But for Mg2 plus, you need 2 Cl minuses to cancel out the positive charge. And like I say, we have these ion chips in class, and I can show you them when we go to class. So the formula would be MgCl2. But there's a shortcut. There's a shortcut to doing this. The shortcut, now you can add up all your charges and try and get enough ions so that your charges end up to be 0. But there's a much easier shortcut. And the shortcut is to cross the numbers that go with the charges down. So we have FeC2 plus and Cl minus. If we want to find out what the formula of the compound is that we make from those two ions, we take the 2, put it on the Cl, take the 1, although we're not showing it, and put it on the Fe, and we don't have to show it. So the formula would be FeCl2. So don't take the sign down, just the number. And if you check, 2 negative charges will on the chloride, will cancel out with the 2 positive charges on the iron. So let's do the same thing with Ca2 plus and Cl minus. What would be the correct formula of the compound be? You can't change the charge on the Cl, but you put a 2 down here. Yep. So you cross the 2 down. Yep. So it would be CaCl2. For Fe2 plus and O2 minus, you could cross the 2's down, and you might think it would be Fe2O2, but reduce to lowest terms, because if you notice, you've already got 2 plus and 2 minus, so it's already 0 charge. You don't have to do anything. So the correct formula is just FeO. For Na2 plus and O2 minus, or Na plus and O2 minus, what would the formula be?
It would be Na2 plus. No. Yes.
Put a 2 down,
Yes.
and you don't have to put anything on the O, just a 1. So Na2O. Na plus with a 2 and O with a 1 on it. How about this one? Na plus and Cl minus.
You wouldn't have to do anything.
Right. It's just Na plus and Cl minus. One Na plus and 1 Cl minus. And Al3 plus and Cl minus.
Al3 plus Cl minus 3.
Right. With a 3 in the bottom. Good. And how about Al3 plus and O2 minus? Just cross the numbers down. So take your 2, put it on the Al, take your 3, put it on the O. And if you count up your charges, you have 6 positive charges and 6 negative charges, which will add up to 0. Okay, let's see what else we have here. I think we're almost done. We've only got 2 slides to do. So we are doing the formulas here for binary compounds. Binary compounds are where you have 2 different ions. In terms of the ions, what we've been working with so far are what are called simple ions. Simple ions are the ion of an element. So if you take fluorine, that's an element, and you make the ion from fluorine, make F minus, that's a simple ion. Polyatomic ions are ions that are made up of more than one element. They're basically charged molecules, is what they are. So some examples of some polyatomic ions are OH minus, where you have an oxygen atom and a hydrogen atom together, and they have a charge of 1 minus. NH4 plus, you have nitrogen combined with 4 hydrogens, and the charge of this one molecule is positive. CO3 has a 2 negative charge, SO4 2 negative, PO4 3 negative. You won't find these in the periodic table because they're combinations of elements. But making the formulas works the same way as we've done before. So you have Na plus as an ion, OH minus as an ion, and you just need one of each. So the formula for the compound that you make from that would be NaOH. For Ba2 plus and OH minus, you need 2 OH minuses, so you cross the 2 down. So the formula would be BaOH2. Notice, though, we put brackets around the OH, because if we didn't, the 2 would be right beside the H, and it would look like we've got 1 O and 2 H's. But that's not what we've got. We actually have 2 OHs, so we put brackets around, so that avoids the confusion. So whenever you have more than one of a polyatomic ion, you have to put brackets around. We could also write this okay. We could separate out the elements and write it as BaO2H2. which would tell us how many elements there are. That's the correct number of elements. But this is a little better because it shows that we actually have an OH polyatomic ion. And that is it, I think. I've just repeated the slides, so we are done. So the next thing for you to do would be to practice doing the equations for ion formation. And there will be some examples at the end of your chapter for that. I have a worksheet for practicing making up the formulas, so you could start the worksheet. You actually finish it and hand it in Chapter 5, because once you made up the formulas in Chapter 5, you'll name them. So I'll get you the worksheet you can practice on. So those are the next two things for you to do. Practice the equations for ion formation and practice making the formulas for ionic compounds.
Can I do the assignment yet?
Probably do the worksheet first before doing the assignment.
Okay.
And the lab we can do, we could do the lab next as well. The lab we can do anytime.
Okay.
So let's plan to do the lab tomorrow. And for those of you watching on video, let me know, come see me or whoever your instructor is if you have any questions.